Let's begin. Today's December 3rd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 7, 10, 18, 19, and 21. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally, criteria card F. Criteria card A takes a look at our last digit, the circle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution, and the Turing Machine will let us know how many of those digits are 4. Are there no 4s? Is there a single 4? Perhaps 2, maybe even all 3 are 4. Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again takes a look at the 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where the solution has a pair, as in the example 131, or alternatively, there are no pairs, but there are 2 scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card A. Okay, so the Turing Machine approves of my choice for circle. Notice I did pick an even 4. So the Turing Machine confirms that yes, circle is an even digit. So let's go ahead and type that up in our notes in section A. And we'll say that circle is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. Okay, I think the next thing I'd like to test is criteria card C. Okay, so again, the Turing Machine does approve of my choice in proposal 314. And notice that criteria card C is adding up the digits. So let's go ahead and do that. So 3 plus 1 is 4. 4 plus 4 is 8. 8 is an even quantity, and the Turing Machine approves of that. So let's go ahead and type up that note in section C. And that is that triangle plus square plus circle should be an even quantity. And so let's see what that reveals. Well, we already discovered that circle is even. So if we want the sum total to remain even, either both triangle and square are both odd or both even. And that's because when you add 2 of the same type, either 2 odd or 2 even, that sum total thus far is even. And of course, we're going to add that circle digit that's even. And so even and even does equal an even. So again, we're looking for a solution that might be either 2 odds and an even, or an all-even solution. Now, it is interesting that we do have criteria card B, the number of 4s, And what else? Well, again, we do have this criteria card D, where we're adding up the first two digits. So let's go ahead and test criteria card D. Okay, wow. So that is also true. So notice that we are adding the first two digits. 3 plus 1 is 4, and 4 is less than 6. So it is true that the sum of the first two digits should be less than 6. So let's go ahead and type that up in our notes in section D, and we'll say that triangle plus square should be less than 6. And let's see, what does that reveal? Well, in order for the sum total to be less than 6, neither triangle nor square can be a 5. Because even when you add 5 to the smallest of 1, that total is already 6. So obviously anything bigger than 1 would also yield something that's greater than 6. So let's see, anything else? So we're down to kind of a 50-50 between two evens and two odds. Well, let's see. Yeah, we are. Well, let's do this. I think we've already completed our 3 Turing tests, and we're now going into the phase where we'll be discussing how to construct a good second round proposal. Let's see, we did not test B, the number of 4s in our solution. At this point, I guess you could have possibly 2, I suppose. Circle could be 1, and then either triangle or square could be another. Oh, but remember, oh yeah, we do have to have a sum total that's even. So either they're both odd in triangle and square, or both even. So yeah, I don't think you can have only 2. All right. And then I guess what's outstanding is criteria card E. Are there a pair or are there no pairs? Okay. Well, the one obvious thing is we got 3 check marks in the first round. So could it be that we have the solution already in 314? Well, that's a possibility. Anything's possible. Could it be, well, why could it be 314? What in the criteria cards would help us determine that? Well, if it's 314, that means that there would be no pairs. And so let's see. If there are no pairs, if there are indeed no pairs, then yeah, I think, I don't think, if there's going to be a 4, it could only be in circle, because if 4 were in triangle or square, then that would force us to have a 1, and then that would break our pattern of either both being the same type. So it would have to be 4 in circle, but then how would we choose between 3, 1 and 1, 3? Yeah, I don't see it being obvious how either triangle or square could be a 3 or a 1. I just don't see the criteria cards pointing in that direction. So definitely I'm going to change my solution. And that said, I don't think it could be, again, 1 and 3, so it must be an all even solution. So it must be let's see. How do we force? Oh, let's see. Yeah, so I think it must be that there's going to be a pair, and it's got to be 2, 2, 4. That's the only possibility. There's a single 4. Yeah, because I think if you have a pair, it can't be a pair of 4s, because then that would mean that you're forced to have a 2 and a 4 in triangle and square, and that is already a sum that's greater. So, yeah, this is an interesting puzzle where it seems like you're kind of forcing the issue that triangle and square must be 2s. Could it be a triple number? Well, let's see. If it's a triple number, how could we somehow deduce something? I was thinking somehow, seeing if we could tell whether circles should be even or odd. No, I don't see that. So, okay. So, yeah, so I think because the sum has to be less than 6, yeah, I think we can actually outright remove the 4s from both triangle and square. And that is because in order for us to pick a 4 in triangle or square, that forces the other digit to be a 1, which doesn't make sense. And so, let's see, we could have, and at that point, you do have 1s and 3s, which you can pick from, and that's fine. You could say it's, no pairs, but again, how do you choose the ordering? There's nothing there. So I don't see how you could have a 3 or a 1. And so, yeah, I think we're forced to have 2, 2. Now the question is, do we have a single 4? Well, let's see. Can we make some kind of argument between criteria cards B and E? If you have if you have a triple number, it's either all 4s or they're not all 4s. So that would tell you whether it's 0 or 4, but they are distinct cases. Let's see. I really do want to say 2, 2, 4 where there's a pair. Oh man, I really don't want to go to a second round, but I think I'm going to have to. Okay, so what would be the best? So I am going to test 2, 2, 4, but should I test criteria card B or E? I think the best one would be E. So yeah, let's go ahead and test 2, 2, 4, because I'm just wondering, can it be a triple 2? That's what I'm trying to guard against. But let's test 2, 2, 4. and we will test criteria card E, the number, to see if there is a pair or not. Okay, yes, so there is a pair. And so what we'll do is, let's type up in our notes and say that the solution has a pair. And it is going to be a pair of 2s, so we're going to deduce that there's a single 4. So we'll type in here deduce. Four-digit. Yeah, and okay, so we do have a pair, so let's kind of make the quick argument. We know the 4 couldn't be either triangle or square, because if you had a 4, that would have to add up with a 1, and that would break the sum total of being even. So that means that the pair has to be up on top, and it would only be 1, 1 or 2, 2. So the 4 goes down here. So how do you pick between 1, 1 and 2, 2? Oh, that's good. How do you know? How did we cross out the 1s? Huh. Well, I know we crossed out the 1s because of the 4, that there were no 4s. Well, wow. How did we I know we crossed out the 1s because of the 4, but that doesn't necessarily preclude the fact that they couldn't be 1s. 1, 1, 4 does add up to be an even quantity. I don't remember that. One, 1, 4. What's wrong with 1, 1, 4? It's a pair. Well, now I'm really wondering, could it be something like a 2, 1, 2? No, it can't be 2, 1, 2. Okay, so now I'm really, you know what? I think I do need to test criteria card B, because now I'm thinking, could it be 1, 1, 2 now? Yeah, let me test B. Okay, look at that. So it did not like the fact that there's a single 4. So that means that a single 4 is invalid. Wow. So bad deduction here. Yeah, so I'm glad I took a look at that 1, 1 again. So there is no single 4-digit. So it did not like the 4. So yeah, wow, that was a close one. So that means that this is a 2, and because there's a pair, it's a pair of 1s. Wow. When I review this video, I'll have to see why I crossed out the 1s when I shouldn't have. Again, I believe I was making the argument, well, if there's no 4, there's no 1. And that's not necessarily a good argument. You can cross out the 4s if you want, but just not the 1s. Okay, well, let's review this really quick. And I'm pretty sure now everything is complete here. So is that last digit even? It is. It's a 2. Well, let me type it up. And so, yes, that last digit is even. Based on criteria card B, a single 4 is invalid. It did not like the fact that it was there. So, and technically, I guess I should be saying that I'm deducing 0. So it is correct that I guess it should be, we are deducing that there is no 0. So yeah, let me go ahead and uncross that out. Let's see if I can do that. Yeah. So we're deducing that there is no single 4 digit. Okay. And what else? So the sum of the 3 digits is even. Yes. The sum of the first 2 is less than 6. And there is a pair. So if there is no 4, yeah, it must default to a 2. Okay. Wow. That was close. So let's go ahead and verify 112 as a solution. 112. All right. Well, how did we do versus a Turing machine? Well, it was a 5 criteria, or it is a 5 criteria card puzzle, and we did 5 tests. So that's a pretty good indication. So we did A, C, D in the first round, and then the remaining 2 in the second. So let's type that up. So A, C, D in the first, and I believe B was incorrect. Yeah, that was the number of 4s. So that was incorrect. But there was a pair of digits. Okay, so we beat the Turing machine by 1 question. Well, I've got to say that this is probably the best save that I can recall, just in the nick of time, when considering, I don't know why I was looking at 1122. Ones were already crossed, but it just seemed like, hey, that's possible. Well, what about you? How did you solve it? What criteria cards did you pick? And did you discover anything interesting that you'd like to share? Add those ideas to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.